What are the types of services we have in the Kubernetes? What are the types of services? So we have the cluster IP, node port, load balancer, external name, then we have headless service. Okay. So we have one more networking related resource that is called as Ingress. So, so if we have the services inside the cluster also, those can be exposed outside by using an ingress. So that means we can provide an external access to the services in a Kubernetes cluster by using the ingress, and even we can do HTTP, HTTPS level, like we can load balance them, and we can do the proxy. Okay, so then we can do TLS termination using ingress. So what ingress is doing is, ingress is providing external access to those services, and it's providing like proxy kind of service to those services. That means before service, we have the ingress and redirecting to that service based on our decisions. Okay, then we can do path-based routing, or maybe like we can do the path-based routing also we can perform using the ingress, and TLS termination also. What is the concept of TLS termination is, if we have any of the traffic is coming over the HTTPS, we can decrypt that one to HTTP. So that is also is possible with the ingress, like a ingress resource. So now normally in the services, cluster IP is only for the internal service, but we can access over the internet by using node port or load balancer. But here the problem is, for each and every service, like for the deployment kind of thing, like we need to use, each service need to use one cloud load balancer. It's very expensive kind of thing, and even little tough to manage also. And if it is node port, it's hard to use in the production because we have the limited ports for the large scale microservices. With these limitations, we are not using the load balancer services. Suppose we have the 20 microservices. To expose the 20 microservices, we need to use internet, we need to use. Okay, so that means each load balancer we need to use means it's very expensive kind of thing. With all these reasons, we are going to use, with that we are going to use load balancer, we are going to use.
Ingress.
But with all these reasons, we are going to use the, sorry, we are not going to use the load balancer. We are using ingress, we are going to use. And in order to work with the ingress, by default, ingress doesn't work on the Kubernetes cluster. On top of the ingress, we required one controller. That controller is called as Kubernetes controller is required. So we require the Kubernetes ingress controller is required. By default, with the Kubernetes controller, ingress controller, we don't get it. Explicitly, we need to install, because we are getting node controller, pod controller, endpoint controller, like this, the controllers we are getting, but we are not getting, ingress controller won't come by
Ingress.
default. But if we want to use the ingress resource, then we need to use, the, then we need to use the like ingress. If you want to use ingress controller is required. And with the ingress, what is the thing is, say I have one domain, I want to redirect to one microservice, I want to redirect to another domain, I want to redirect to another like a microservice. Okay, so like this different domains you can redirect to different microservices we can do. And host based routing, path based routing, TLS termination, load balancing, authentication support, all these are possible with the ingress. And if we want to work with the ingress, what is the mandatory thing is, ingress controller is required. Ingress controller is required. Okay, so we have the different ingress controllers we have. That means by default, we can't use the ingress. On top of our Kubernetes cluster, what is the prerequisite is? What is the prerequisite? Ingress controller is the prerequisite. Ingress controller is the prerequisite. Okay, so then like what are the different type of ingress controllers we have in the market is, so we have the Nginx ingress controller we have. So we have the Nginx ingress controller we have. So one of the most widely used ingress controller. But if you are using EKS, we are going to use the AWS application load balancer ingress controller we have. And if you are using GCP, GKE level, or like a Azure level, we have Azure Application Gateway Ingress Controller we have, or Istio. So we have the different ingress controllers. We have what are the different type of ingress controllers we'll discuss. On the same Kubernetes cluster, we can have the multiple ingress controllers also can be installed. Okay, so ingress controller is one of the Kubernetes controller component which will configure the network rules, all these for the ingress. Okay. So now here, whenever the traffic is coming, say with the ingress controller, like we'll create a load balancer. Say if you have 10 microservices, if you use the load balancer, then we require 10 load balancers need to be created. But if you use the ingress, what is the advantage is one ingress is enough. Then that is going to redirect the traffic to the ingress controller, and ingress controller is going to match based on the host path, and based on that it is going to take the decisions. Okay, then traffic is sent to the service is going to discover that corresponding pod, and to that it is getting redirected. To that pod it is getting redirected. That is the communication flow is going to happen. Okay, so then here the first request will send to, like maybe in the AWS wise we are going to hit to route 53 to maybe any of the load balancer we are going to use. The load balancer to we are going to redirect to the
Ingress controller.
So ingress controller we are going to hit. Then from the ingress controller to the service. Then the service to
Pod.
like to that pod it is getting redirected. Okay, so like this the communication flow is going to happen. Okay, so with that the communication flow is going to happen. Okay, so then like ingress controller we are going to set up. Then we are responsible to configure the ingress rules we are responsible to set up. Now, what is the API version? What is the API version?
1.
V1.
Okay, no. Networking.k8s.io/v1 and kind is the ingress. Ingress controller, we no need to be responsible. There are a lot of ingress controllers are designed. Like we need to choose one ingress controller, and that's we are going to select. Okay, so that's we need to select. Okay, so depends upon our requirement. We need to choose one ingress controller. Now, say here, what is this TLS? I will explain. And how many number of hosts we have is, these are our domain names. In the outside, we are going to create, say if this is the requirement, in the route 53, we are going to create 2 hosted zones we are creating. App1 dot that domain name, app2 dot domain name, 2 hosted zones we are creating. Then in the rules, if it is app1.example.com, I'm redirecting to like one service, I'm redirecting app1 service. If it is app2.example.com, I'm redirecting to app2 service. That means in the backend already we have, two services, and backend the services we may have deployments or maybe stateful sets, daemon sets we may have. That's going to create the pods. Directly we don't create the pod, maybe deployment, stateful set, daemon set we have created, and to that service, like if it is app1.example.com, it is redirecting to app1 service. If it is app2.example.com, it is redirecting to
App to service.
app2 service. So that's like how many load balancers are required here? How many load balancers are required? Only one load balancer is getting created with this ingress resource. Okay, so only one load balancer is getting created, and here this is like a host-based routing. That means depends upon the domain, we are redirecting to that. So it depends upon the domain, we are redirecting to that which we want to use. Okay, so then path base is same domain, but I have my two different URLs are there. What is the meaning of path-based routing? Have the two domains, but two different URLs we have. Depends upon this path, I'm going to redirect to that service. Then the API version is same, Ingress. Then I'm going to use that domain is same. If it is a path is /app1, I'm redirecting to one service. If it is path is /app2, that is same domain name, but I want to redirect to two different like a domain path base. I'm going to take the decisions. Then I'm going to use the even Ingress. Say here also depends upon the path it is going to take. You can have different 15 paths also you may have, but Ingress is going to take that use case. Okay, so that means my application same, say suppose maybe paytm.com, but /payments are different, orders are different, /authentications are different. So then like we are going to use for one application URL itself, we have the different paths we have. Those paths can be taken care by
Ingress service.
by the Ingress. That's path-based routing we are going to configure. That path-based routing we are going to configure. The second one is multi-domain. That means I have two different domains, but same, like I want to redirect. That is also. And the main another advantage is one cloud load balancer. Otherwise, if I have 20 microservices for two applications, total 40 microservices, 40 load balancers are expensive. Now here also we have the services, but what is the type of service we are creating? Because Ingress is redirecting to service only, right? What is the service we are choosing here? What is the type of service we are choosing? What is the type of service we are choosing? The service is internally cluster IP itself. Even it is cluster IP also that can be exposed to outside by using Ingress
Load
controller.
balancer.
You got it right. Internally, that's maybe a cluster IP service also. That is cluster IP scope is within the cluster itself. That can be exposed outside by using the Ingress resource. Okay, then what is the meaning of HTTPS offloading is like the traffic is coming from the external users over the internet using the HTTP for the security purpose. At one point, we need to choose the point where that communication need to be decrypted. That's called as HTTPS offloading. That is called as HTTPS offloading. And that in that HTTPS offloading, what we are going to choose is in the HTTPS offloading, what is the point we are choosing is at the Ingress level itself, we are decrypting. That means from the Ingress to the backend services and to that part, the communication is going to happen over the HTTP only, but from the external user to till Ingress, because that came to our network already, that's not going to be over the public lines. Maybe the internet data may be traveling over the like the ACT guys or like internet guys, Hathway guys, Reliance, they will have the cables outside, but that is not secure. But these Ingress is in our office environment or maybe in the private network environment we have. That's the reason we are going to be like offloading point is Ingress we are choosing. And even weighted kind of deployments also we can do. Some percentage of traffic goes to this, some percentage of traffic can be goes to Ingress. So these kind of things also is possible to set up. Okay, so now we can use the different type of Nginx, we can use those also. Okay, so now service is like we can use the node port or a load balancer, but like Ingress is more powerful and cheaper also. And we have the different type of Ingress controllers. Okay, so we have the different type of ingress controllers we have. So to work with the ingress object, definitely on our cluster we require the ingress controller. Otherwise, ingress resources we can't create, because by default we don't have that in the Kubernetes. So we have the different type of ingress controllers. We have Nginx ingress controller, traffic, HA proxy, AWS load balancer, or we have AWS ALB ingress controller, application gateway ingress controller, Istio gateway, or Envoy based counter, HA proxy, or F5 big IP ingress. So most of these companies are load balancer kind of companies, and even they are providing these ingress controllers also. We are choosing, depends upon our requirement. You tell in the EKS environment. Previously, we have the Nginx ingress controller, and currently we are using AWS ALB ingress controller. We are using, and currently in the Azure application gateway ingress controller we are using. Okay, so those some set of routing rules is configured in Ingress, and Ingress controller is like a controller kind of software that reads and execute those routing rules. But we require different load balancers are required for the load balancer service. Okay, so load balancer, but Ingress, one of the problem is it supports only HTTP and HTTPS protocols. You have any other TCP kind of thing, those kind of things, we need to expose using, we can expose using like a load balancer only. Okay, so that means Ingress works only for web itself. That means HTTP, HTTPS, not for other TCP or UDP level. Okay, so then Ingress like is the best resource for our use cases. The one external load balancer we are getting when an external IP, and that handles multiple microservices, multiple applications also it can perform. And even we can do the path-based routing, host-based routing, TLS terminations, all these also can be performed. That means we have backend lot of services. We want to give one front end for the multiple paths or multiple applications, multiple microservices. Then like Ingress is the best resource. And we want to do the path-based routing also, TLS termination and smart routing features, cost optimization. Okay, for all these, we need to go for Ingress, and it's mandatory. We require an Ingress controller. In the cloud, it's easy to create an Ingress controller, and the Ingress resource cloud-based is creating application gateway or maybe AWS application load balancer kind of thing. But in the on-premises also, we need to set up one load balancer, hardware level load balancer. That's maybe networking team, you can tell that's taking care. Okay, then here we'll discuss, we have an app and one front end we have. Okay, just want to expose that. Then directly we can use load balancer. But we have a microservice base. We have front end, user API, order API, admin portal. Say we have the different URLs we have. Then we are going to take the decision is the ingress controller, and we can expose only one service. Then that services we can use. But if you have TCP base is there, again it's not HTTP base, then definitely we need to go for
Load balancing.
load balancer itself, because Ingress can't support that. Okay, so Ingress can't support that one. And internal only also we can use internal Ingress also we can use, but we have the multiple rules. So it depends upon our requirement. We need to choose whether to go for load balancer or ingress. So now we have the YAML files basic host base. Means we have the two hosts, and we already discussed this. Like if it is the host is one domain name, I want to redirect to one microservice. If it is another host, so this host name meaning is our domain name. Okay, so based on the domain name, we are going to redirect. And the path is same domain name, but the application paths are different. Okay, so that is called as path-based routing. Then the host is same, but we need to configure multiple paths. We need to specify. We need to specify the multiple paths. Then, like we can configure even the TLS termination also. We can configure. What is the concept of the TLS termination is? Like we need to generate a certificate. That certificate name we are adding. That means this TLS certificate is not the certificate. Already we have created the certificate of that like a key that normally you may see Verizon, GoDaddy. So those all will provide the like TLS certificates for us. We are purchasing those certificates. In the AWS, we have ACM. AWS certificate manager we have. That AWS certificate manager is providing the certificate for us, and using that certificate, we are going to add to, because if I add this certificate here, everyone can see that that's contained the certificate, and that private key is contained. Optionally, intermediate key also may be there. So that's the reason we are creating that as a secret, and in the ingress we are passing as a TLS. We are passing in the TLS. We are passing that. Okay, so based on that, we are going to set up that. Okay, so we are going to configure those rules. We are going to set up those rules. We are going to set up, and based on that, we are going to take that to which path. Path here slash means to the home directory. It is that means to the home path. It is redirecting. If I give slash apps means that is the URL. To that URL, it is redirecting. If I give the path is slash means to the home, it is redirecting. Okay, even if I want to traffic redirection should be done through like a SSL forcefully, I want to redirect, but we don't use this use case because mostly the HTTPS traffic itself we are converting into HTTP. Okay, but if I want to do that HTTP traffic forcefully, I want to do to HTTPS also, we can redirect. But at some point of time, that need to be decrypted. Okay, even if the user hits a slash shop, this is the path, I want to redirect to home itself. That is also we can redirect. In the annotations, like we are specifying rewrite path is slash, whatever the path user is hitting, the backend service I'm redirecting to /1 itself. And in the canary deployment, what we can do is number 80 means that is the weight. 80% of the traffic is going to be redirected to one. Another 20% of the traffic would be redirected to another. These kind of ingress rules also weight we can provide. So whenever we are doing that 10% or 20%, these kind of things we can specify. And for rate limit, mostly in the Kubernetes we are using like web application firewall we will configure. We don't directly use the ingress. What is the meaning of rate limit is, say if we hit that website maybe for 100 times, 200 times, I don't want to allow from the single IP. That may be like maybe a bot kind of thing, or like maybe they want to flood our website with that URLs. So most of the companies even say, suppose if you use the ChatGPT also with the free account for more hits, they're going to limit you for some time. So these kind of features are called as rate limiter. That means I want to stop only rate limits are per second. I want to 5. More than that, if the user request comes, I don't want to. allow that more than that. I don't want to allow that for more than 5 times. Okay, so that's we need to specify. Even we can do the rate limit also, but in the AWS on top of your application load balancer, there is a feature called web application firewall. There we are going to specify these rules. Okay, so we don't mostly use Ingress for these all the purpose. Application level also, application code level, they are going to write the authentications, all those. Okay, if you want optionally, we can use for all these also, we can specify. Okay, so then we have the ingress rules, but that is not working as per the expectation. Then we need to troubleshoot. Okay, so that's first, what are the ingress resources we have? We can get it from the Kubernetes, kubectl get ingress. Okay, from all namespaces, if you want to get, then use capital A. Then because by default it shows only from the default namespace. Or if you set the current context of the namespace, what you set, from that only we can get that. But I want to get from all the resources or namespaces, -a we can give. Then describe that ingress and ingress name. What are the annotations, rules we have, and even the backend parts, services, those are working or not. Mostly, even if the ingress rules wise everything is perfect, even we need to troubleshoot whether that controller logs also we need to check that. So whether that controller logs also we need to verify. Okay, so describe those logs also at the ingress controller level also. By default, ingress controller is running in the kube system namespace, not with our application namespace or with the default namespace. Most of the Kubernetes internal objects are working using kube system namespace. Okay, and even that service wise also we need to check service to pod logs also. We need to check that. So like this, even we need to get that service, describe that service, endpoints are there or not. If the endpoints are empty, means that application is not able to communicate. And the pod level also, pod to service matching based on the same selectors, and all those are there or not. These all the things we need to check that. And the backend parts also should be running. And sometimes that certificate what we have given, maybe secret is wrong, or that secret certificate may be expired also, may be the problem. The certificate secret also may be expired. Okay, so that secrets and certificates also we need to check. The rules also may be matching rules. So we don't have that service name or path may be given wrongly. Okay, so that's also maybe some issues. Path type is prefix or exact matching should be done. Some DNS level mismatch. So these all like we need to check that. So we need to check the ingress logs, ingress like controller logs, service logs, pod, secrets. Then paths have been configured, matching labels, annotations, all those has been given or not. The ingress itself is not available means that's maybe like that load balancer. What is the the backend again is create one load balancer will be created. So which ingress controller we are using, all those also we need to troubleshoot. Okay, so these all like from that ingress level, we need to troubleshoot all these. Okay, so that means definitely people will ask us ingress, and one rule YAML code for the ingress also we should able to write. Then like what are the probes we have also. So what is the meaning of probes we'll discuss, and ingress troubleshooting also, and load balancer versus the like ingress. So what is the load balancer versus ingress? Okay, so then we have the probes. Okay, so what are the probes we have? So we'll discuss what are the probes we have. We'll discuss. So what is the meaning of probes are? Like this is also very important question from the interview wise. Okay, so what is the meaning of probes or the health checks? How the Kubernetes is going to use. So Kubernetes, one of the feature is Kubernetes having lot of self-healing kind of features. That means if there is any problem in the cluster or on the application parts, there are some thousands of parts are running. Kubernetes has provided a built-in self-healing kind of mechanism has been provided, and that is called as Kubernetes probes we have. So what is the meaning of probes are? It's a self health check kind of mechanism or self-healing kind of mechanism. Whenever we have the thousands of parts are running, like we no need to troubleshoot those. By default, we'll have the internal health check kind of mechanism can be configured by probes. Okay, so the probes will decide when to restart the container and when the service need to redirect the user to a running pod. Okay, so when to start the container, even if it is start like this, we have very important three probes we have. Okay, so what are the types of probes? Also very important question. And what is the use case of those probes? Also is very important question. So what is the meaning of probes? What are the types of probes we have? Is generally the probes are self-healing kind of capabilities. Okay, so then we have the three types of probes we have. One is liveness probe, second one is readiness probe, third one is startup probe. So what are the types of probes we have? So we have the liveness probe, readiness probe, and the startup probe we have. Okay, the first one is liveness probe. If any of the container is failed or any deadlock kind of situation happens, we may have some thousands of pods. For each and every pod, admin no need to go and verify. If I configure a liveness probe, if the container is not working, or if a deadlock kind of situation happened, or if it is alive, then automatically the pod is going to restart that. If the pod itself is going to restart that one. Okay, so what is the meaning of liveness probe? What is the meaning of liveness probe? If any of the pod is in not alive state or a deadlock kind of state, automatically that pod is going to be restarted automatically, because even if a admin goes, he also is going to perform the same operation. But if I go for a liveness probe, what is happening? Automatically it's getting restarted. If I go for a liveness probe, automatically that pod is getting restarted. Okay, then we have the readiness probe. What is the concept of readiness probe is if any of the pod is if any of the pod is not in the ready state, then the service is going to remove it from the load balancing, because always the user request should be given to the healthy pods, and if any of the pod is not in the ready state, then that service is removed from the load balancing of that. So with this, what is going to happen is that service is automatically removed from the load balancing. Then unhealthy pod is not going to be given to unhealthy pod is not going to be given to unhealthy pod is not going to be given to the users. Unhealthy pod is not going to be given to the users. So that means if any of the pod is unhealthy, what readiness probe will do is it will be removed from the load balancing, and always the service doesn't redirect the traffic to the unhealthy pod. Always the user request should be sent to
Healthy pod,
the healthy pod. Who is going to take that?
readiness probe.
Yeah. What is the difference between liveness probe and readiness probe? Okay. So if there is any problem, or if the container is failed, like that's going to restart that pod automatically. So mostly that's going to give the solution. But even if it is not, like if it is there is a one like mechanism also, this many times only it need to restart. Continuously also it won't restart. If it is failed within a short span of time, if it is restart also, it's not going to start. It is going to keep in a crash loop back kind of error also we are going to keep. And even that is also one of the common error we would be getting in the Kubernetes environment, and we need to troubleshoot. But most of the times, if any of the pod restarts, it may be working fine. But even consecutively, if that pod restarts also is not serving that, then the pod is going to keep in the crash loopback kind of error. We'll discuss that. And if I configure a liveness probe and readiness probe, automatically the parts, if you have any issues, is going to restart that. But if I have a startup probe, what is the advantage of the startup probe is, it's not going to work like a liveness probe, readiness probe until it passes. What is that meaning is, till the like a first time when the pod is starting, it won't do liveness probe and readiness probe, because I have an application. For every 5 minutes I configured, or my application pod is taking like maybe 300 seconds like this. But what is the problem here is, if the time my application is consuming more time to start up, then like liveness probe or readiness probe would be keep on restarting that probe, that pod. But my application, only for the first time it is taking more time. Okay, so then we need to enable startup probe. If enable startup probe, then like what is going to happen is liveness probe and readiness probe is not working. Okay, liveness probe is, readiness probe is not working. This is useful in the use cases where your application time is more than the expected time. For the normal applications, it's not an issue, but I have a problem with some microservices that startup time is more time it is taking. At that moment, what we need to do? We need to enable startup probe. Only at the time of startup, it will suppress liveness probe and readiness probe. Otherwise, what is the problem is, it's keep on restarting and the startup is not happening. It goes to that kind of deadlock kind of cycle. That means it never starts that. That is the reason for the first time what we are doing. For the first time what we are doing, at the time of startup, we are stopping those liveness and readiness probe. Those liveness and readiness probe, we are stopping. Okay. So if you use the liveness probe, always that pod is running. If the liveness probe fails, then Kubernetes kills that container and restart it. That means liveness probe is keep on probing that that service is running or not. If that is stopped, means it automatically restarts that. Okay, so if any of the application has been hanged or freeze, even if an admin goes also, what he will do is he will restart it only. Okay, so that's we need to configure that liveness probe, and it's keep on checking that health of that in this path that application is running or not with the port number 8080. Then it's automatically is going to restart that. Readiness probe, if I configure, if that application is ready to serve the traffic, okay, so then like it's going to be removed from the service discovery load balancing. That means service never redirects that request to that pod. Okay, and if I enable startup probe, so for all the parts maybe not required, but which of the parts required? For which of the parts is required? More time is required. For those only we are going to use
Startup probe.
startup probe. Is at the time of
Whenever
application
start the startup
launching,
probe,
it is going to suppress the Liveness probe and startup probe.
Readiness probe.
Yeah, once it is successful, then only liveness probe and readiness probe will work. Okay. So these all we are going to specify in our pod specifications, either with the deployment or stateful set or daemon set. According to that, these probes also is going to work. So you have any store startup microservices, then better to use startup probe. And application may be freezing randomly, and each and every time admin need to go and restart that pod, then better to configure liveness probe. And before traffic sending to that, I need to confirm whether that application is working and healthy. Then only I want to redirect that. Then readiness probe I'm going to configure, and even dependency is also working. Readiness probe, we have one more init container is there. That also I will explain. Static pod, init containers, sidecar containers also we'll discuss. And even in the deployments also, readiness probe is very, very important. If the backend any updates are happening, those like to the healthy parts itself, it is redirecting the traffic. Then like here, initial delay, period seconds between the probes, timeout seconds, failure number of failed attempts, success threshold. Only for the readiness, this many times it should be success. These all that like the main advantage with the liveness probe is it's one of the self-healing kind of feature. Because most of the times, if the pod restarted, that problem may be solved. And always the healthy service itself we can redirect by configuring the readiness probe. Okay, and application launch times, these all can be managed by, if you have a slow startups, we can control it from
Startup probe.
startup probes. Okay, so these all important from the interview wise. Then in the AWS, we have the auto scaling group for the EC2 instances where we can scale up the number of instances. In Azure, we have VM scale set, like where we can manage multiple number of instances depends upon the load. But in the Kubernetes, we have like a HPA that's called as a horizontal pod autoscaler, VPA, vertical pod autoscaler, and cluster autoscaler. Okay, so these we'll discuss in the next session. Like these also very important from the, like every object, whatever we are discussing is one interview question. So we don't use all these in our job every day, we don't use it, but we require the knowledge in all these. Okay, and there is one add-on on top of Kubernetes that's called as metric server. Okay, that metric server is also is mandatory for HPA, horizontal pod autoscaler. So that's we'll discuss in the tomorrow session. We'll discuss that. Okay.